So let's finish up this chapter 8. These last 3 problems are different from these other 2. These last 3 problems have more than one variable, and that makes them more challenging, to be honest. So when there's more than one variable, we have to set up more than one equation. These first 2 have 2 variables, so we're going to have to set up 2 equations. This last one has 3 variables, so we'll have to set up 3 equations. It is quite tricky, but we'll save it for the end. Starting at number 3, an elementary school has 18 times as many students as teachers. And the number of students and teachers together is 608. So I'm going to say the students plus the teachers equals 608. And then I also know that the students, there are 18 times as many students as teachers. And that's kind of hard to wrap our head around the words on that. A lot of times we want to say 18 times S, but think about it a little bit in like real life context. There's always more students than teachers. So if there's 1 teacher, there should be 18 students. If there are 10 teachers, there should be 180 students. So the students is the answer. It's the big one for this. 18 times something, 18 times the number of teachers is going to get me a bigger number than 18. So S is equal to 18T. Now, what I'm going to do is I'm going to substitute this in. So everywhere I see S, instead of writing S, I'm going to write 18T. Because what this equal sign means over here is S is the same thing as 18T. They are exactly the same thing. You know, sometimes like I think about my oldest son. His name is LaRue. We call him LaRue, but a lot of his friends just call him Rue. He's the same person, whether he's LaRue or just Rue. Just goes by something slightly different. Same thing here. Instead of S, kind of the, you know, that would just be the Rue. We're going to take the time and call it its fancier name, LaRue. So instead of S, I'm going to write 18T. Going to combine those like terms. 18 plus 1 is going to give me 19T. I'm going to divide by 19. So I get 32 teachers. Now, I wasn't asked about teachers, but I'm going to go ahead and label them. Ask about students here. So to get the number of students, I'm going to plug that in to my student formula. 18 times 32 is going to give me 576 students. Now, like I said, each one of these is kind of slightly different. So I am going to help you set up this next one because it's not quite as straightforward, but then I'm going to have you try the substituting part. So 1,200 tickets are sold at a concert. We've got adult tickets and student tickets. Now, when I'm making these 2 equations to try to figure out these, like which one numbers go together, I think it's a little bit harder than 3 up here. 3, it was a little bit easier to see which numbers go together. 4, I tell people to look for the units. The ones that all have dollar signs are going to go together. The adult tickets are $12 each. The student tickets are $8 each, and the money total was $11,200. So that's my first equation. My second equation, there aren't any more numbers to use with those, or not that many more numbers to use. Don't reuse them. The only number I have left is 1,200. So that's a total. That's equal to all the adults plus the students because those are the only 2 ticket types I was told about. So don't reuse numbers. We usually have one of those that's pretty straightforward. You can see it. Here's that A plus S. There's that S plus T. Very similar to that. This one actually has a couple different ways to work it. I'm going to keep doing substitution since that's what we did before. I'm going to choose one of the equations to get the variable by itself, to isolate the variable. I'm going to choose the one I've got highlighted because I think that's going to be the easiest one. So I'm going to come over here to the side, choose either variable. It really doesn't matter which one that you choose to get by itself. I got A by itself. I moved S over. And A is the same thing as 1,200 minus S. So now I would like for you to try to pause and try to solve this problem using that substitution. So go and see if you can finish out and try to substitute that into the equation. All right, let's see how you did with that substituting. I've already used the one highlighted in green, so I'm going to substitute into the other equation. So I'm going to get 12, and instead of A, I'm going to write the fancy word for A. And what happens when I do this is I get rid of one of the variables. I eliminate one of the variables because we can only solve an equation if it has one variable in it. We cannot solve it if it has two. So that's the whole point, is to eliminate that problem. Don't worry about negatives until you get down to the end. Sometimes people get a little nervous, like at this step, because there are going to be some negatives in here and people think they've done something wrong. You cannot have a negative for your final answer, but you could have it earlier on. So I'm going to rewrite that. Doing my algebra, moving it over. That is an S and not a 5. I know it's kind of hard to read that. That's going to give me negative 3,200. Let me rewrite. That's an S. When I go to divide by -4, this is going to take care of all the negatives. And I get with my student tickets, there were 800. That's actually what this problem asked for, were student tickets, so I could stop right there. If I needed to know how the number of adult tickets, I know it didn't ask me that, but I'm going to go and do a little bit more than necessary. I can plug it in for either equation for S. I'm going to do the easy one though. I'm going to be a little lazy. And get the number of adult tickets. Oops. I plugged it in wrong. Let me just go back there. I plugged in the wrong number. So I'm going to plug in for the number of student tickets, 800. And go ahead and subtract that. And get the number of adult tickets was 400. Problem didn't actually ask for that, but just in case it had.